So a video I've wanted to do for a while for you guys is I wanted to kind of go over the difference on the gas lenses versus the standard collet body on the AC side of welding. When I first started welding aluminum here in my garage at home, you know, I just slap a gas lens on and go to town. I had great luck with it. You know, I wasn't good enough to really see a difference or really quite understand what was going on, so I just went with it. And then as I started to get more better at it and wanting to really perfect my skill level with it, I started to realize that there is a difference here in the two. And what happened was I was picking some people's brains. I love to just, you know, ask questions. I've always been like that. I want to learn. And, you know, I was talking to my good friend Mark Winchester one day, and we were going back and forth, and I was telling him about some issues I was having with some stuff, and he said, "Man, are you using a gas lens?" And I said, "Yeah, I am." And he goes, "You know, you can't, you got to get rid of that." And so it really pushed me into wanting to understand here what's going on with the two. So I started really doing a deep dive into this. I started running a lot of tests. I started trying to understand what the difference was in the two, why some guys are saying one's so much better than the other. In the welding community, you got one group of people that love the gas lenses on aluminum. It's all they'll use. And on the other side, you got a group of people that say, no, standard collet body and standard cup is the only way to go. So that really intrigued me to really research this and really learn okay, what is actually going on here? Why are some people saying one thing, some people are saying another? So I've seen some videos on this. I don't really agree with all the videos I've seen from what I've learned here. So I thought, you know what, I'm just going to make my own video. I'll kind of go over with you guys what I have learned and what's working for me. And that's how I kind of want to approach this. But the first thing that really caught my attention was me being in the piping industry. On the high purity side of things, we used to do a lot of aluminum piping. And I started to go back and look at some old welding procedures. And the first thing I noticed was all the welding procedures on the piping side for aluminum stayed out, standard collet body, standard cup. No gas lens. And then I started talking to some people in the aerospace industry. I'm not in the aerospace industry, so I don't know how true all this is. But they're all telling me 99% of the time, our welding procedures stayed out. We're not allowed to use a gas lens. We can only use a standard collet body and a standard cup. And I'm like, okay, why is that? You know, why is the American Welding Society or some of these welding engineers and stuff, why are they saying that the standard collet body is better? So that's when I started really researching this. And I think the first thing we have to understand is what the gas lens was actually designed for and what its purpose is. So anybody can look this stuff up. It's all available online. But the gas lens was designed for reactive metals: titanium, stainless steel, Hastelloy, Inconel, super duplex, things like that. Carbon steel that need that large blanket of gas to protect them from the atmosphere at all times. So then, how does a gas lens actually work? Well, gas lenses just have a screen in them that's known as a diffuser. And then what happens is the gas comes out of here. The screen's purpose is to diffuse the gas evenly throughout this orifice size and give you a nice blanket of gas. And there's a lot of good pictures out there. I'll try to find one and put it in here where that can actually be seen. And what's happening is, being that that's slowing down the gas path, it's not allowing the atmosphere from around the weld to now mix in with that argon gas or that shielding gas. So now, when we go to the standard collet body, we just have 4 holes. The gas is coming out at a higher rate of speed because there's no screens in there to slow it down, and it's just dumping out of this orifice size. So we know that. But why is that better for aluminum than the gas lens? So then I started researching aluminum itself. And the first thing you read is aluminum has its own oxide layer present on it anytime it's in the atmosphere. So right now, this piece of aluminum has its own oxide layer on it at all times. And the other thing I read was aluminum, I've been told my whole life that aluminum is a non-reactive metal. Technically, when you start reading, and anybody can look this up that doesn't believe me, aluminum is a very reactive metal. Because anytime aluminum is present in the atmosphere, it has oxide layer on it. If you take aluminum, say you took this large piece of aluminum and you put it in a ladle and you melted it down, there'd always be an oxide layer on top of it, unless you had a way to make that whole ladle, everything around it, inert. The only true non-reactive metals that I have read about are gold and silver, platinum, and palladium. Okay, not aluminum. So that really was one of them things to where I'm like, okay, wait a minute. I've been told aluminum's non-reactive. Why are they saying it is now? So that was the first thing. What makes aluminum different? So I think the next thing we have to understand is how aluminum is actually welded. Yes, aluminum can be welded with DC, with helium. I know that's an aerospace thing. I've never done it. I know it's a very sooty, dirty weld, but a very high penetration weld. It can be very strong done that way, but I have never done it. I have no experience in that, so we're not even going to go into that. But what I do know is how aluminum is welded with AC. So you have your positive and your negative side of your wave cycle. The positive side is for the cleaning, which removes the oxide layer. That's its job. The negative side is the penetration side, which penetrates into the material. The argon's job at that point is to keep that oxide layer off the weld surface as you're welding. That is its sole purpose. So as you're welding, you have the cycle going up and down. The argon's present, and it's keeping that oxide layer pushed off the weld so you can add filler wire and make a nice looking weld. So now that we understand how the AC wave cycle works, and we know that, what makes the gas lens not good for it? So what happens is when the gas path is actually slowed down, that allows a couple things to happen. That allows our arc to widen out. When that arc widens out, now that allows the slower gas path to pick up the arc, which at that point, anything that the gas comes in contact with, now the arc can strike. So a lot of times you'll see or you'll experience to where it seems like your arc is kind of wandering, and you'll see it like anywhere the gas is kind of hitting, you'll kind of see it like sparking almost. So we've probably all experienced that. We've probably all seen it before in arc shots and whatnot. So now when you go to the standard collet body, what happens is, because the speed that the argon is now coming out of that orifice, it's not allowing the arc to be picked up by the gas. It's doing multiple things. The arc now is more pointed and more precise at what you're welding. The arc is also quieter. It's you'll see that a lot, to where you'll hear somebody weld it with the same exact settings with a gas lens versus a standard cup, to where the gas is tuned just right, and you'll notice right away that the arc sounds quieter and more defined almost. So now what I'm going to do is I'm going to try to set up some coupons. I'm going to try to do some arc shots here. One of the things that I noticed when I switched to a standard collet body and cup was, the etch zones immediately get smaller, and more, being in the motor, doing motorsports kind of work, automotive stuff, that people really want the welds to have that raw appearance and really look nice. A lot of people don't want a 1-inch wide etch zone. They want that real nice, even etch zone around something. The other thing I noticed right away when I started switching back and forth was it seemed like I could get a more of a rounded looking ripple with the standard cup and collet body. And this all kind of, really pushed me into favoring this. And then I realized, okay, another big thing for me, which is, I'm here in my garage. I can run a lot less argon with this than I can with this. Okay, so that's going to save you money. So what I'm going to do is I'm going to set up some coupons. We're going to run some beads with the gas lens with a number 8 cup, and we're going to run some beads with a number 5 standard cup on just some plate, and we're going to see if we can see the difference. So we're going to try to set that up. We're going to try to make some welds here for you guys. I'm going to try to get some mark shots. I don't know how good they'll turn out, but we'll just see here what happens, and we'll let you guys kind of see the difference. So now what we're going to do here is we're going to run one pass here with the gas lens, and I'm going to switch it real quick, and I'm going to run one pass right beside it with a standard number 5, and I think you guys are going to be able to see the difference. Okay, we got the number 5 back on. Turn the gas back down. We're going to run a pass right beside it. Kind of hard to tell by the video, or by the picture there it's showing. It looks worse than it is. But if we measure this, right under a 1/2 inch, almost 3/4 of an inch there. So you can really see the difference. I mean, it's hard to see in that picture. Let me zoom it out and zoom it back in. But you can really see how this puddle and this bead profile is a lot more uniform than the gas lens. You can see how wide these etching zones are. Now, with me telling you guys this, the last thing I want is somebody to go out and change their setup because I made this video. If a gas lens is working for you and you're having great luck with it, don't change it. I'm not going to tell you it's wrong. I'm not going to tell you you have to switch. All I'm trying to show is what I've learned, what I've came up with, and what works for me. You know, at the end of the day, if a gas lens works better for you than a standard cup, by all means use it. The one thing I do know is when you slow that gas path down with aluminum, it does make it a little bit easier to control. You know, another big downfall to using a standard cup is you have a lot more tweaking with the gas. You know, when you go from different joints and different weld configurations, you got to mess with the gas a little bit more. So I'm not going to say that a gas lens is totally, you know, useless and you shouldn't use it. I'm not saying that. All I'm trying to show here is what works best for me, what I've learned, and, you know, kind of what I've came up with here while I'm learning this. And that's all this video is intended for. You know, I don't want anybody to get upset about this video. I know that, you know, there's a lot of controversy, like I said earlier, out there on this, but, you know, that's what this video was for, was just to try for me to explain why I use a standard cup over a gas lens. That's all. So I hope this video helped somebody. I hope you guys, you know, enjoyed it, and I hope you all have a great day.